Now, there are some types of questions with GPs that require us to either use logarithms or to use trial and error. Now, we're using logarithms because, of course, GPs are all about multiplying by common ratio, and we end up with indices in our working. So this example question is a good way to show how to solve these. And the main point that I want to get across is choose whichever method that you like to solve the problem. I'm going to solve this as many ways as I can think of, but all of the ways are going to start the same, and then I'm going to break up into some different strategies. So for this GP, 2, 6, 18, ... find the first term that is greater than 1 million. Okay, so what do we know here about this GP? Well, we know that the first term is 2. Can we figure out the common ratio? Well, 6 divided by 2 is 3, and 18 divided by 6 is 3. So we're multiplying by 3 each time, and we figure it out by doing the second term divided by the first, double checking that it's the same as the third divided by the second. So R is 3. That means I can easily come up with, now we know the formula for a GP for the nth term looks like this. So for this GP, I can say the nth term is 2, because that's A, times, and I'll just put it in brackets, 3 to the power of n minus 1. So now I've got a nice little formula I can use to find any term. Now, which term do I want to find? Well, I want to find the term that's greater than 1 million, and I want to find what n value that's going to have. Then if I want to, I can find what the actual term is. So it's a two-step process. Find what term is going to give you a big number, the size that we want, and then you find what the term is second. Alright, so what do? Well, I'm going to start by saying, here's my formula for the nth term. I need it to be greater than 1 million. Okay, solving this to get the n by itself. The first thing that we want to do is divide both sides by 2 to get rid of that. So we've got 3 to the power of n minus 1 has to be bigger than 500,000. Alright, what next? Alright, here's where I'm going to break into a few different strategies. The first strategy that I'm going to use is just trial and error, because it's quite simple and straightforward. So one way would be to say, well, I'm just going to try some stuff. I'm going to grab my calculator, and I'm just going to say 3 to the power of something is greater than 500,000. What could it be? Now, pick a number. 3 to the power of 10. What's that? Well, it's 59,000. That's quite a bit too small. All right, 3 to the power of 15. What's that? Oh, that's much too big. So it's in between 10 and 15, and it's actually not taken me very long to already narrow it down. I know that this number here, the n minus 1, is between 10 and 15. Let's try 12. 3 to the power of 12 is 531,441, so that looks good. I better just check that 3 to the power of 11 doesn't also work. No, that's too small. So I've just found with trial and error that 3 to the power of 12 is greater than 500,000, and it was quite quick and easy to do. So then if n minus 1 must be 12, then n must be 13. Okay, now if n is 13, I can easily see what the 13th term is by just saying, all right, the 13th term is going to be 2 times 3 to the power of 12. What does that give me exactly? Type it in, 2 times 3 to the power of 12, and that is 106,282. So now going back to my original question, what's the first term that's greater than 1 million? The 13th term is greater than 1 million, and it's 1,062,882. So now I've answered the question. So that was my working for the trial and error. Let's solve it with different working now. Somebody who's comfortable working with logs, as you guys should be, even though you're potentially a bit rusty, might like to solve it by saying, look, I get confused when I see this greater than sign. How about I just solve this? And then I can think about whether it needs to be greater than or less than afterwards. Easy to rewrite this as a log. 3 to the power of n minus 1 is equal to 500,000. So what's n? Well, we need to add 1 to both sides. So we've got 1 plus. Now, how do you put this into your calculator? You need to use that change of base law, remember? So we need to do either natural logs, using the base E button, or log to the power of 10, to the base of 10, doesn't matter which, as long as you're using the same button for both. Chuck that into your calculator and see what you get. Now, what you're going to come up with here, let's put it into our calculator to see. We've got 1 plus giant fraction log of 500,000 over the log of 3 equals 12.94. Now, when you come up with that answer 12.94, that's proof it was equal to. Now, we want to find one that is greater. So you're going to either want the 12th term or the 13th term. And thinking through, this is getting bigger as it goes up. So if the 12.94th term, which doesn't really make sense, does it, is equal to the thing we want, then to be bigger than that, we're going to need the 13th term. And so then you can go ahead and find the 13th term exactly as we did before. Somebody else who is even more confident working with logs might say, no, I can go straight away here and write this as a log. And I can say 3 to the power of n minus 1 and put my 500,000 here. And I know that the n is on the big side, so it's got to stay on the big side, and I can write it up like that. They can go ahead and solve it. They'll get to the point where they're saying n is greater than 12.94, so it must be 13. Same thing. Yet another way to solve it would be to say, all right, at this step here, why don't we just take the log, base E or 10, doesn't matter, let's go E this time, of this side, and take the log of that side. I've taken the log of both sides, so it's still balanced. Using the power law now, this power comes down the front. So we have n minus 1 times the log with a base E of 3, and on the other side we've still got the same thing. Now to get the n minus 1 by itself, we need to divide both sides by this log 3 with a base of E. So we've got all of this divided by that log of base 3, and then to get the n on its own, we need to do all of that plus 1 on both sides. So all of that plus 1. Put that in your calculator and you'll get that same thing of n must be greater than 12.94, and so then your reason n's got to be a whole number, must be 13, and we still finish off each way with the same working. So the take-home point, logs are super helpful for getting to the answer quickly, but only if you're good at using them. Sometimes it pays to use trial and error, could even be quicker. And the other advantage of it is you've already put it in, so you can verify that your answer works with numbers that make sense to you.